Hello, welcome to my talk. I'm CB Bailey. I work at Bloomberg. I work in the infrastructure team. We provide. I, I always find it so hard to kind of like say what we provide because it's so much, and there's so much kind of context which is kind of difficult to summarize. But essentially, we provide a framework for applications at Bloomberg to communicate with each other in an efficient and easy manner. And what we provide is kind of tools, so code development tools, libraries, APIs, a code generation tool, and also another part of my team provides actual software items, so gateways, routers, depending on which side of the Atlantic you are. I think we have routers on both sides of the Atlantic. All of this to support basically passing messages between components. And it's mainly kind of oriented around a kind of client-server framework generally, and sort of mainly request response is our kind of principal model. So if you think of it like HTTP REST, before that became kind of popular, it does a similar sort of job. Used by kind of, I would say most application teams at Bloomberg. People write a service that can respond to various requests with various responses. That service itself might be a client of other services. And it enables cooperation between many teams at Bloomberg. You can find my Mastodon there, which is reasonably quiet. It's not going to flood your feed, that's for sure. And so the particular thing that I'm going to be talking about is our code generation tool and how we integrated it into other people's builds. So as I mentioned, this is all about interoperability between services. And the way our framework works is we allow, encourage, enable application owners to define their service in a language neutral way in a schema. And we happen to use XML schema definition language, XSD, which is a choice that was made a long time ago. It serves its purpose. It's not the greatest thing to author, I would say, but it's definitely at least provides a definitive definition of types that a service can support. So it's a way of defining, if you like, an API in a language neutral way. So why generate code? So if you're defining your types in a language neutral way, but you want to write C++, which is the principal language we use at Bloomberg. It's not exclusively C++, but it's certainly the major one supported by our team. Then you don't want people to kind of like define their service in terms of an XSD and then hand code the thing that meets that specification kind of separately when generating that code would do it without any of the manual labor. So you can specify our types in a language agnostic way. You don't have to write the boilerplate to get usable types in C++ or any other language. And I'm a strong believer that the source code is useful to humans as well. So if I'm writing an executable that's going to talk to somebody else's service, I can look at the service, the specification for the requests that I'm allowed to send and the responses that I may receive back. I can look at that in the schema definition language and understand the shape. But when I'm actually kind of writing the code that's going to interpret that sort of stuff, I don't want to have to do that mental leap of going, okay, so this is what the XSD is. So the class that I'm interfacing with in C++ is going to look like that. I want to actually have the header file there so that I can quickly go, oh yes, it's dot this field or dot that property, extract that, decide what to do with that particular piece of data. So that bit about the source code being useful for humans will come back later too. So we have a pre-existing code tool. I see some people in the audience who either currently or in the past have worked at Bloomberg, may possibly be familiar with this tool. It's a very old tool. It's been at Bloomberg for longer than I've been at Bloomberg, and that's over a decade. It's pretty flexible. You can generate all sorts of stuff with it, and it's got a myriad of different options that kind of configure that change various ways in which it generates code. It's probably more than most people realize. I would say that there's probably, there's probably about 15 to 20 Boolean options, a number of things which take strings and stuff. You kind of take that, take all that flexibility, and there's probably, 2 to the power of 30 different ways of generating stuff from the same schema. That flexibility is both a bonus and a hindrance. Makes it very difficult to introduce a change or an improvement to the tool, because obviously the testing matrix is theoretically incredibly large, and given the size of our organization, there's almost always at least one team who's using one particular combination of options that you didn't think would be useful together. Sometimes they're not useful together, it's just an accident, but sometimes it's people use things in a way that's unexpected. Okay, so how is this tool used in the past? So generally, so its original intent, as far as I can determine from tracing through the various source code repositories in which this tool has lived, the original intent was to allow you to, so I think it was mainly designed for the service side, so for you to be able to generate the code that when you compiled it, would use like a stub service for a particular service specification, and just leave you some functions so that you could fill in the implementation of your service. So it would handle generating a main function, standing up some interfaces, receiving requests, working out what the top level request was in any incoming requests from any particular network interface. It supports multiple network interfaces at the same time. It would support a pool of worker threads. You wouldn't have to worry about that. You just wrote a function that said, hey, when you're processing this request, here's a context in which you can deliver the response once you've decided what it's going to be. And then you'd call deliver response, and you'd exit your function, and the worker would turn to the thread pool, the network would handle it up, any network errors we delivered automatically. So it's kind of like generates a whole lot of code, which uses library code that handles a whole lot of stuff for you. So generally the intent was you generate this shell of a service, and then you take what it generated, check it into your source code repository, add your functionality, and just kind of evolve it from there. However, we do change what we generate. We add features to it. So I'm thinking in particular when we have a lot of top-level requests. One of the things that's very useful to service owners to have like metrics, like how much CPU time did this request take, how many requests of this particular flavor am I receiving, what's the average time that I take to handle it, what's the worst case, are people waiting 2 seconds for a response, are they waiting for half an hour for a response? So, over time, we've added metrics, automatically collected metrics. We've improved the way we do that. We've changed the framework we use. So every now and again, you'll find some people who've got the really old generated service, and you'll want them to go to take advantage of maybe the new features. So, yeah, bugging people to regenerate their code from their service when there isn't like an ideal, if they've just customized what you expect them to have customized, that upgrade can be seamless. If they've done some clever stuff that you might not be expecting, generating and merging those changes might be more than the tool was designed to do. So we've kind of like spent some time updating our recommendations about how we expect you to change and what files that we generate we don't expect you to change. And over time, a lot of people have started to generate to run the generation script in various ways, ad hoc, from their build scripts. And we've kind of migrated largely to using CMake, but there are still people who are using other ways of doing it, kind of make files according to a previous best practice. So it's not kind of like, there's no universal way that people were invoking this. So kind of at the same time as we were adopting more and more CMake, a group of developers started to work on a CMake integration, and that proved very popular, and it definitely felt like something that should be officially supported. So my team kind of took it over, and I've really been the person kind of driving the sort of best practice and improvements behind it. So let's suppose, for the sake of example, that you have some sort of a code generation tool that's a bit like ours. It has some sort of like input specification, and it generates some C++ source code. So if you go onto the CMake documentation site, you might come across recommendations of how to do this. Is this text good and readable for most people? I got some thumbs up from right at the back, which is awesome. I've been in a bit of a discussion about contrast and things, and I suddenly thought maybe I should change that to light, but I was too close to the presentation, so I didn't experiment too much. Anyway, that's good to hear. So this is just a summary of some of the options to add custom command. So what does add custom command do? So add custom command lets you add a custom command. I mean, it lets you, it specifies a command to be run at build time that generates some sort of an output that you can use later in the build, and you can specify what command to run, and you can also specify what its dependencies are. Okay, that's good. Some things to note. It runs at build time. So that means, there are two kind of like, in a CMake build, there are kind of two main phases to there are two main phases that I'm interested in build in a kind of CMake build. What I call configure, which is when you invoke CMake for the first time, or possibly for a second time, but without specifying -- build, where it parses all of your CMake lists.txts and anything they include, and generates some sort of a build script. And CMake supports kind of multiple build backends. The ones that I'm most familiar with are Unix makefiles and Ninja. And I highly recommend Ninja if it's kind of if you can support it in your environment, as just genuinely being faster and better. I mean, Unix Make's okay, but it's got a lot of features which are kind of geared around it being the configure and build tool. So it's got a lot of implicit rules that are kind of like just kind of happen to run, and I think they probably, some of them get turned off by a CMake generation, but it's just got a lot of baggage that makes it a bit slower that Ninja doesn't have. So I think Ninja kind of works as a slightly better pure build tool. I think I should have put an extra slide in here just to prompt me where I'm going. So add custom command, obviously it's parsed during the configure step because it's a CMake directive, but the command that it generates is part of the build step. So if you're generating C++ source files, they won't exist until you've actually built for the first time. Another important thing to note is you do have to know, so the output is like mandatory, you do have to know what files are going to be generated by your custom command ahead of time. I should have moved. I did have the prompt. Okay, so your output files must be known ahead of time, and that's kind of an issue. So if you think about our example, and it's talking to a couple of other people already today, it does seem to be not atypical. But if we have a schema which defines your types, then the header files that you generate are going to depend on what those types are if you're following some sort of header file naming convention, which I kind of think is a good idea. And having to specify them in the CMake list as well seems not ideal. You're having to keep two things in sync. The other thing is, like, output files must be consumed by a single target. So this would be if you generate a CPP file and you wanted to compile it in one library and another library or two different executables, it's not a good idea to do that because the rules that CMake will generate in your build file will tend to trip over each other. So you can end up kind of building things twice again. They recommend against it in the CMake manual. And another issue, which actually, so if you do if you configure a project which is using add custom command, if you just run a default build, usually it just builds everything correctly. But if you're doing a bit kind of like, if you're doing something a bit specialist, so supposing I have, supposing I generate a source file in the associated header file, and I've got a manually written source file that uses the generated header file. If I do a clean configure and then try and build just the object file for that manually written source file, it won't necessarily know to run this custom command because the output that would trigger or the dependency that would trigger it running the command is kind of like the link step that needs the object file that needs the source file. And the fact that the header file is like a byproduct and you kind of need that to build this other thing which isn't directly means that, and actually this can happen sometimes with some build backends and not with other build backends. You start like losing the abstraction of the particular build tool you're working, which can be kind of like, it's a bit niche, but like once you trip over it, it quickly kind of becomes obviously irritating, or at least irritating to me. Okay, short demo. So I'm going to try and show you a little project based on this. So, so first of all, is this text going to be big enough for people? This one's a lot easier to make. Oh, let's move into example one. So I've got a little. So the nice thing about this, is that big enough? Back at that one? Yep, good, cool. I mean, you know, if it's a bit of struggle, feel free to move forward. So this is kind of like a reasonably simple project using add custom command. CMake minimum required, standard boilerplate. Can't remember why I chose 3.116. We're on to about 328 at the moment, although if you're on Debian old stable, as I am on one of my machines, 316 is not supported. Old stable, I think, is good, and stable, absolutely fine. Project tells me which languages to use. I've got an interesting point about this later. Oh gosh, I'm already 20 minutes in, and I'm suddenly realizing how big this presentation is. I'm going to move a little bit faster. Find program, I'm just, so I could have hard-coded the path for my generator, which I've called gen.pl, but this is a way to allow searching for generator.pl. So if you have a build environment where you install your generation tool, then this will work. I've also specified a custom path which is relative to this source directory, and I've actually got it in tree, so it'll find it there. Look up find program documentation for the order in which it searches things. It's very flexible. But using find program rather than a hard-coded path at least gives you the opportunity to do some sort of kind of customization with your paths from outside of your editing your CMake lists, which can be useful for testing and things. Add executable, it's just generating a, I did uncheck this is a beginner talk, so if you're coming here to learn the very basics of CMake list, you'll probably have to go away and check your documentation again, but like you'll get a summary here. So add executable creates a new executable called example.1 and says that these are the two source files that you need to generate object files to link into it. Target include directories. So add custom command, you can customize what directories the output goes in. But by default, it will go into the build directory or CMake current binary directory associated with this source directory. And I tend to think that's the sensible option. I have very strong opinions about build processes that generate stuff in the source tree. I think it's wrong. Thank you. but I'm happy to talk about that later if anybody needs to be corrected. But because of that, and because I'm generating header files in the binary in the build directory, and I've got some source files in the source tree, I'll need to add that as an include path. So target include directories does exactly that, and then add custom command says, hey, I've got this custom command. I call the generator, which I've found through find program. I call it on this input path. The working tree by default will again be in the build tree, so I have to specify a path to the source tree. So generator, I call it on my YAML file, and the dependency of this command is kind of obviously the YAML file that I'm passing in, and the output will be to these two files. So I'll just show you, I just wrote a really simple generator, and I said, hey, this is just some YAML. I'm going to generate a class called generated with members, one member. It's going to be called value trailing underscore. Every presentation, I like to choose a really bad member variable distinguishing convention. I've chosen the trailing underscore. I'm sure there's a good, I can't remember whose great book used that first. Type int, and I'm going to put it in namespace ex1. Okay, and main's very simple. I just use the generated class. And one thing that I did, I'll show you. Actually, let's build and run it. I'm going to have to go faster. I can see. Nothing up my sleeve. And I'm going to build this source directory. I'm going to build it into a build directory called build. I'm going to use Ninja. If I left that off, it would just use Unix makes files by default. And it's generate some build files. So cool. And now I'm going to actually I'll give you a few seconds to look at that. So it does some detecting of compilers, does some figurating, and it writes some build files into the build directory. So if you look in the build directory, there's a build.ninja, and there's some other stuff, and there's a CMake cache and things. Okay, cool. So let's now build, and I just run CMake --build. Rather than changing into the directory and running Ninja or changing into the directory and running make, because running CMake build prevents me from having to remember which build tool I used. I'm going to do -v so you can see what's happening. And you can see here what it runs. So changes into the build directory, runs my generator, builds the main file, builds the generated file, and then links my executable. So if I now look in my build directory, you can see there's the generated files here, and I'll just show you one of these. So if I show you this, it's really basic. It's just a struct. I created a function that you can call purely so that it would force me to actually link in the object file. Otherwise, maybe I'd have missed that out and it would be an incomplete example. But you saw in main, I called ignore me, and this ensures that I've got the linking correct and the generated code is indeed being linked into the executable. So I'm just going to quickly pause there. So, any got any kind of questions about how that works or what it does? No, cool, excellent. Everybody's asleep, doesn't care, or is following perfectly. All of which I'm absolutely fine with. Cool. Okay, one thing else I was going to show. So because I specified the dependency to the add custom command correctly, if I run the build again, it's got nothing to do. If I were to edit or just touch my YAML file, it correctly regenerates it. Both my source files depend on the generated header file, so they get rebuilt, and of course the final executable will get reloaded. That's, I think, incremental builds are really, really important. Getting that right, really important. Okay, cool. Okay, so there's another command. You can have a custom target, and yeah, okay. This allows you to have a command that's not linked to a particular output. So I said earlier that you have to know what the output files are. So add custom command would be a way for you to run a command where you didn't know what the output files were. The issue there is now you still don't know what the output files are, and it's difficult kind of to depend on them. But add custom target can be useful in some scenarios. There's no dependency checking because there's no output, so that the command is always run. So if you've got like an expensive command, that can be bad. It does have some uses, and I'm going to show a use of this later. Okay, cool. So what's an alternative to both of these build time generation? Well, obviously, another option would be to have configure time generation. So in order to achieve generation of code at configure time, you can build some functionality around the CMake function execute process. Execute process executes a process. It's CMake's function, naming conventions top notch. Does exactly what it says on the tin. So execute process will happen while CMake is parsing your CMake lists. It won't get run again unless CMake is run in configure mode once more. But here's an important thing. The output of whatever execute process does can be used during configure. And this can be kind of pretty important. So there are kind of like two things that I kind of think are important. So one is if you're generating some files at configure time, you can then inspect the file system and see what files have been generated, and then add those output files to libraries or executables, and that's kind of important if you don't know what they are. So that kind of addresses the problem of not knowing what the output files are for add custom command. And the other thing is you can kind of pass them to an install step. So if I generate header files, I might want to have them as part of my install so that when they get packaged, the package for my library, including header files and archive files, is complete with all of the header files you need. Yeah. So this is an approach that we took. Another important aspect is that, which is, I'm not sure how particular it is to our environment, but one thing that we're doing more and more on Bloomberg is running static analysis tools on as many of our builds as possible. But in order to run static analysis tools, we don't have to build the project. We usually just have to configure the project, and then we can use, you can get CMake to write out what the commands are needed to compile your project, and then a static analysis tools can take those compile commands and then view the various things like the macros and the include paths that you're running with, and run either the same compiler but with some other diagnostic or another tool that understands those same things. If your generated code isn't available after a configure time, that can kind of not work. And you may not be interested in running static analysis over your generated code because maybe you're confident in the tool that it generates stuff that passes static analysis. I wouldn't be that confident. I think it's good to run static analysis over your generated code. But not only that, if your source file includes a generated file, static analysis may fail on that handwritten file as well, which is kind of not ideal. So generating stuff at configure time solves that problem for us, and I'm not sure how widely applicable. I think that probably is reasonably applicable. Yep. Okay. Cool. I hope you didn't work at the same company as me, because otherwise that's just a echo chamber reinforcing. But yeah. So. At this point, I would definitely recommend writing a simple CMake module to package up the task. So here's an example CMake lists file for generating code at configure time using an external generator module, and it's pretty simple. Just find the package that's like generator, add the executable, and then say, hey, generate code into this target based on this input configuration file. Okay, so as you probably worked out from that previous slide, the complexity has been moved into the module, and the module can be reused for anything that wants to generate code. So I have a kind of slight bugbear that a lot of people kind of like A lot of people stop addressing modularity and good code practice once they leave C++, and then you hit the build files, and they just do everything they can to just get it work. I don't want to think about it. And I'm the sort of person who goes, this isn't right. I want to think about this too. So I love modularity in CMake setups too. So this is it's an example of a config-based CMake module. So if you call it config, and then you use find. This is an error in this slide, is there? No, there isn't an error in this slide. Just going to go back a slide. So if you use find package will find a CMake module, and there are two kind of discovery mechanisms. There's config mode and module mode. And if you're really interested in the differences, you can look it up at CMake documentation. But in my opinion, config mode is the easiest one to set up, and the way you do that is you end your module with the word config.cmake and put it somewhere in a path that is either common to your system or is specified in your find package invocation. And then inside your generator config.cmake, you put the code that is needed to do generation. So top of the file, CMake minimum required. I've upped the version a bit because I'm going to be using some more recent features of CMake, just exhibiting the fact that your modules don't have to require the same minimum version, so long as you're using a version of CMake that is high enough for everything that you use. We've got the same find program specification, and now I create a function. So the function is going to be called generated code, and it's going to take two arguments, two named arguments, target, which is a CMake target, like a library or an executable, and input, which is like an input file, so my YAML file in this case. Okay. Always good to sip slightly less water than you think you want, pause, drink more water. I've drunk as much water as I wanted immediately before, and it sometimes ends a bit noisily. Okay, so there's going to be kind of like a couple of phases. There's going to be a pre-generation setup, and then there's going to be a generation step, and then there's going to be some post-generation tidy up. Okay. So first thing I'm going to do is I'm going to set up a path, and I'm going to create a subdirectory of the build directory for this, for whatever source directory we're currently in. So I'm inside a function in a module, but CMake current binary dir and CMake current source dir both refer to where this function is being invoked from. It's not specific to this particular config.cmake. It's specific to the original CMake list.txt, where the function is being called from. So I set up a working directory, so it's going to be called generated code. It's going to be a subdirectory of the current build directory. I'm going to make that directory. I'm going to add the directory to the include directories for this target. I'm then going to, so because I'm like going to be running this generation tool during the configure step, I want it to run, so my tool generates stuff into the current directory. So unlike add custom command, where it gets run at build time, kind of in the build step, if I want to run it somewhere other than where CMake was invoked from, I have to kind of like I have to be careful and be a bit more explicit about where we're going to run it from. So I'm going to create an absolute path so look, the input path will be in my source tree, and I kind of want to be able to refer to that as a relative path from where I'm running the tool, whereas that's kind of handled automatically in add custom command. I feel I said that confusingly. Does somebody want me to say that again? Does it kind of like, you have to be careful with the input path relative to where you're running it, whereas add custom command handles that for you when you're doing build time generation. There we go, that was better. Okay, so the last one is the really, really important thing for incremental builds. So you remember before I just touched the input file, so I touched ex1.yaml, and I ran the build again, and it noticed that that changed and it updated. Now that I'm doing configure time code generation, that's not going to happen automatically. However, if you run CMake -- build and you've changed one of your CMake lists, CMake embeds in the build rules, by default, a little rule that says, hey, if the CMake lists have changed, don't build before you've rerun CMake to make sure any changes to the CMake lists have been updated for you. That's really useful. And what you can do is you can add to the list of things that will trigger that by updating this directory property called CMake configure depends. So what I'm going to do is say, for this directory, add the input path, so the YAML path, to the list of things that will trigger the build tool to do a reconfigure before it actually does a build. And this is kind of like really important for those incremental builds. Okay. Now the generation step. I happen to think that the first thing is like really important. I like to see when special things are happening when I'm running CMake. And I happen to think that running the generator is one of those important things. And I think the severity level of notice, which is kind of like, I think it's somewhere between info and warn. It's not a warning, it's not warning, but it is like an important step is happening. And we're going to run execute process. And if you remember, generator was the generator which we found with find program. Input was the normalized path to the input YAML file in the source tree, and working directory is the working directory set up. And then command error is fatal any. Really important, especially if your code generation tool does report errors via status code. Way too easy to, if you don't put this in, execute process returns non-zero, nothing cares. So maybe the generation fails. Maybe that will cause the build to fail. Maybe it won't. So particularly if you've already run the build once, and then maybe you update your YAML file with invalid syntax and you don't notice, you run configure again, it reruns configure, a whole lot of logs scroll off the end of the thing, runs the build, and you get a weird error, and it's kind of like, or maybe worse, you don't get a weird error, but you don't get the changes you expect, and you kind of end up kind of going, I don't know what's happened. Put command error is fatal equals any, and at least you'll get told when the configure step fails. Or you'll trigger the configure step to fail when the generation step fails. Cool. And now for the post-generation work. So after we've generated the files, we'll have, so this particular tool that I've generated and our tool will generate a whole lot of stuff in the working directory. And simplification for our tool, but absolutely true for this example tool, it will generate CPP files and header files. And the important thing we'll want to do is add these source files to the target. Another thing we might want to do is add the header files to a file set that we're going to install so that when we install our library and associated header files, that's complete. But for now, I'm just interested in filtering out all of the newly generated files in the working directory, and if they're source files, I'm going to add them to the target. Cool. So this is the step that allows us to not know or care what particular source files we're going to generate at generation time, but still have them included in our project. And that's it. End function. That's the entire module. Cool. Slightly longer demo. Should we see this on action? And also, it's kind of like seeing the real-world examples too. So example 2. CMake lists. So this is the entire project CMake lists. And I think it's reasonably simple and easy. So instead of find program to find the generation tool, we just find the package that provides the generate code function. And in this particular example, I've given it a particular path. But if in my build environment, the generation CMake module was part of the install, it would probably just be find package generator required, and that would be it. Required means fail if you don't find the package. If I didn't put the required in, you'd carry on going, and then it would just say, oh, generate code isn't a function that I understand. But you know, sometimes you can have optional packages this particular one is very much required for this. And then add executable, and then I call the generate code function. So if I open the config, I've actually kind of split this out and put this all on the slides, but just to show you it's basically the same thing. Find program, the functions generate code, this is the preamble, this is the execute process, the actual generation, and here's the file globbing and adding stuff. Okay, so again, nothing up my sleeves. There's a generated2 function, or a generated gen2orator folder. I'll come to that later. But I'm going to do roughly the same CMake command, this one, but in this directory. I love reverse search in Bash. It's so fantastically useful. You only have to get typing correct once. Okay, so what happens here? I've just run the configure step. I haven't run the build step. And it's done similar things. It's detected a compiler. And then there's that output is from my message notice thing. It says executing generator for, and then gives the path to the source file. And then it says the build files are written out to source example2 build. So if I look in build, I've got a build.ninja file, I've got CMake cache, various other things. I've also got that folder that I generated called generated code. So if I look in there, I've only done the configure step, I haven't done the build step. I've already got the files that I need to compile, they've already been generated. And then if I do CMake build, oh, I should have, let's just show off some more CMake commands. Let's clean it again, and then run it with verbose. You can see here there are only 3 steps, not 4 steps, because the generation has moved from build time to configure time. And all we're doing is compiling the main function, the generated code, and linking the two together. And again, if I touch my YAML input file, because I updated the directory property to say, hey, reconfigure if this other thing also changes, if I run build now, you'll see that it has done step 0 of 1, is to run CMake -- regenerate during build, okay, whatever, with the source and build directories that are appropriate. And so it, as part of that regenerate during build, it's executed the generator. So we've got up-to-date generated CPP and header files, and then it's gone through and built the 2 source files and linked everything together. Okay, any questions about that setup? Yes, microphone.
Is it possible to execute, let's say, the generator after the build files have been created?
So to execute?
So, I mean, for example, you want to parse a Visual Studio project file, for example. Mm-hmm. This has to be generated first, okay? So you have to go through the configuration generation step displayed by CMake, then write the bit files to the directory, and then you might want to execute some script. Not for this example, but for example, for my case, it might make sense. That's why I'm asking. Are you aware of any way to?
So is it possible to execute something after you've written out the build files, but before you run a build?
Yes, at the configuration step, let's say.
I don't think so. I mean, you would... yeah, I think you'd have to either put a custom command as part of the build and have it run early in the build step. But as part of the configure, I'm not sure you can do anything after the build files have been written, because I think that happens after CMake's executed everything. You can get closer, and I'm going to show you something that probably doesn't quite help you, but but maybe you don't know about. So there's a deferred feature as well. I don't know if you've heard of the deferred execution part. Anyway, we'll come to that in a moment.
Okay. We can discuss it later if you have some ideas. It would be great.
I didn't...
we can discuss it later if you have some ideas. It would be great.
Sure.
Thanks.
Yes, towards the front.
Hello. Very small remark. I think it's advisable that you also depend on your generator. So in the case your generator gets updated, that this gets rerun. Say, for example, you get a new version of your generator, which generates one CPP file more than before. Your glob is not going to pick it up.
Yes. So it's definitely a good idea to depend on your generator. In general, you might have an environment, so it depends. Usually that's advisable. If you expect your generator to be updated, then that's definitely a good idea. I think for most people, at our organization kind of like develop in somewhere, but they kind of install their dependencies, don't expect them to change, and if they do update them, they kind of throw away their build directory because they're bringing in stuff that's potentially API incompatible anyway. So that's not an issue we hit very much, or we would hit very much, but we do that anyway, but in a way that I'll kind of show you later. But yeah, I think that's a very good point. Another thing that's that we have is that our generator is based not only on the input specification of your types, but also it has an array of template files as well. And so it's good to depend on both the generation tool and the template files and your source. And so I'm using YAML here. We use XSD. Also, our XSDs can be hierarchical, so you can consume types in higher types libraries. Everything that gets read in by the generator is a dependency of what is generated. So yes, ideally you add all of that into your generation step. And that set property thing is kind of like annoying, difficult to get that to update. So that's something that I know we're slightly deficient of in some scenarios, but it tends not to hit us very much. I mean, on a practical side, in production builds, we don't. There are so many ways to build at our organization, but the modern build system we encourage most people to do is like modular. So a package is built from source in a sandbox with only its dependencies available. It's built, it's published. Other packages that depend on it create their own brand new sandbox, install their dependencies in. And so for production builds, that doesn't hit us at all. But for people's incremental builds, most people I speak to tend to like get all of their dependencies and then hack away. And if they're upgrading it, because they may move something that it is a ABI breaking change, they need to throw away their build directory anyway. So we kind of like, it's great, it's very important, and we largely avoid having to do that for various other reasons. Cool, but thank you, yes. Any other kind of comments at this point? Cool, let's move onwards and upwards, or rightwards. Gosh, it's so confusing being backwards. Okay, issues with configure time generation. And I think we possibly may have touched on some of these. All generation happens sequentially. So CMake in configure mode is basically like a top to bottom interpreter. It reads the top CMake lists, goes from top to bottom. If you include other CMake things, it disappears into that, interprets that, comes back again. If you do add subdirectory to include a CMake list at a lower level, it'll go into that subdirectory and parse that CMake list, come out of that, and it's just a sequential linear follow through the path of the CMake files, and then it gets to the bottom and it's done. So every time you hit, and so in particular for our situation, if somebody wants to so we had that generate code call. If you want to generate code for this input file into this target, and also this file into this target, and also this file into this target, and maybe these into this other target, every time you hit execute process, it essentially stops, goes and executes the process, globs all its output files, adds them in, comes back again, hits the next execute process. So our Perl tool is not the most performant. Thank you for the laugh. Can spot the people who I work with. And so this is kind of like, this can be like, and you know, the bigger the project, the more of a concern it is. Regeneration only happens on any reconfigure. So again, you have to trigger the reconfigure, and that's the dependency issue coming back. And if you do reconfigure, every execute process is run again anyway. And this is another issue. So if you've just got a naive generator that just writes out the files with no regard to whether the output files have changed at all, it means that every single generated source and header file gets touched again, so that your next build might be an almost complete build and won't be very incremental. So that's kind of an issue. So let's improve the implementation. How could we get something that's more performant, but still has the advantages of configure time generation? What if we had a build at configure time? So this is what we do, and this is where I kind of leap into, this is really cool. Wouldn't it be better if there was a slightly easier way to do this? And you're going to see why in the coming slides. Okay, so what I did was, actually I did something more complex than this, but essentially the idea is, instead of executing process every time somebody calls generate code, the idea is that every time somebody calls generate code, we think about it and make a promise to generate the code later on in the process. And what we're going to do is we're going to write out a brand new CMake lists in a particular directory set aside for the purpose, and then run all of the generation tools in parallel at the end of configure. And this has the obvious performance advantage, provided you're kind of building in parallel, but also has a number of other kind of spurious benefits. So the setup. So what we're going to do is we're going to create a new directory, which I called code generate. And we're going to have it at the top. So you'll notice the top path is relative to CMake binary dir. Now you've seen CMake current binary dir, which is the build directory associated with the current CMake lists that we're executing. CMake binary dir, without the current, is the top level build directory. So this is going to be a single top level directory. And now we're going to use the CMake language defer feature. And for reasons that I'm not giving myself enough time to explain, you pretty much, I thought about this long and hard, thought, do I really need to put my CMake language defer inside a CMake language eval code block? And the answer was, after a lot of thinking, yes. And if you come and find me afterwards, I will not be able to answer why either, because it's one of those things that you think about long and hard, sigh, decide that it's inevitable, and then completely forget about because it's just something you have to do. So CMake language eval code says, take this string and execute it as though these were commands were actually in your CMake lists, which sounds pointless, but when it comes to the evaluation of certain variables becomes kind of really important. CMake language defer directory says, call this function when this particular directory has its CMake list.txt has finished being interpreted. So I was asked a question earlier about can you put something off until after the generation step has? No, you can't. This is about as close as you can get, which is so because I've deferred directory CMake source dir, which is the top level source directory, I can defer things until the top level CMake lists has finished being interpreted, but that's still before the build files are written out, which is useful for me because I want this to be part of the build files. So here are two function calls to execute process, which I'm deferring until the very end of the CMake list. And what I'm going to do is I'm going to call CMake itself, which is the I'm just wondering, yeah, no, let's go into this. So there's two forms of, well, there are multiple ways that you can quote strings in CMake. So there's double quotes, which is what the outer CMake language eval code is using. And then there's square bracket quoting, so two square brackets. And there's actually kind of more complex things. There are a few others, but anyway, 2 square brackets is another form of quoting. If you have 2 square brackets around something, it's like single quotes in many other environments in that it doesn't interpret any variable expansion within inside it. But inside double quotes, we do variable expansion. So what you can see is we've got various things like inside defer directory, which are in which are like $CMake source.dir, $CMake command, $code gen build.dir. If they were just inside a square bracket quoted strings, they would not be interpreted. But they're inside a double quote. Now, I know what you're saying, but they're inside the double square bracket inside the double quote. The double square bracket isn't a quote when it's inside a string. It's just some characters. So inside the double quoted string, it goes, can I see a dollar? Can I see a dollar? 2 square brackets, they're just characters. $CMake set. So I can expand that now, but the square brackets stay. And then when the code is interpreted as further CMake directives, so once we've done that first string expansion, and once we're into actually the first step, the things that got expanded are now surrounded by double square brackets. So if they expanded to stuff that had spaces and dollars in, they're all safely quoted and they won't be re-expanded again. And this is one of those things you go, wow, that's cool. I never want to think about that ever again. Okay, so in summary, we are going to run a build at the very end of configure for the top level CMake lists. And these 2 execute processes do that. So they're calling CMake command, which is whatever the CMake was called when this CMake was being involved, -s, -b, -g. So that's a configure kind of CMake command. And then the second one is running CMake again on the same build directory with the build option. So it's very much like a configure and build, but for this magic code generate directory inside the build directory. Okay. I am expecting to lose many people. Does anybody have any questions on that? Great. I've either lost everybody already or they've been following. Okay, so I'm going to run a CMake at the end of the build step, but I need a CMake lists to do for that to work. So I'm going to write out a CMake list file, and this including some standard boilerplate. The project is just going to be called generate code. It doesn't really matter what it's called. So interestingly, I'm using languages none here. Does anybody know what languages none, what the effect that has? Okay, so by default, languages is C and CXX, which is CMake's abbreviation of C++. So whenever you fail to remember to specify project or you don't specify languages, it'll assume that you're doing a C++ project. And the first thing it does, before anything else, is it goes and tries to find what your C++ compiler is, does a test build to make sure that it can compile executables and it understands some standard things, and then remembers what they are so that it can generate the right build files. We don't want to do any of that. And if we put languages none, the CMake invocation, the CMake invocation, if the file contains nothing else, is substantially faster. It's like, it takes like fractions of a second if you don't put this in, and it takes no noticeable time at all, is my way of thinking about it if you do put this in. So that's quite useful. And then we're going to have add custom target. So we're going to have a custom target, but we're not going to give it a command. So this is just like something to hang other things off later. And we're specifying all in add custom target to make sure that this target is part of a default build. Okay, so that's quite simple. So now we come to the implementation of generate code, and we're going to change it, except the pre-generation step remains exactly the same. We still want the working directory inside the current binary directory. We want to add that include path in. And we want to make sure we get reconfigured if the input changes. So that's exactly the same. The generation step, so rather than calling execute process, we replace it with some magic. So because we're putting everything into one directory and we're going to have a lot of builds, potentially multiple generations of the same target, I start creating like a token. So I've SHA-1 some input to make it reasonably unique, and then truncate it to make it pretty likely to be unique, but not too absolutely massive in case you need to look at it. But like, it's just a bit of an art to generate a short, unique, least unique through this project ID for each generation step. And then I create, I'm going to create an output file, which is just something that's going to get touched once the generation step happens. And part 2 is where we add a custom command specific to the particular generation step that we've been asked to do. And so add custom command is something that we've got an output file. So we're going to make that the touch file. And we're going to add the touch file as a source to the top level custom target. So there are 2 commands here in this add custom command. The first is the actual generation step. And the second is just a touch command. So I use CMake command -E touch. CMake basically provides wrap around quite a few common Unix file system commands. You use them, and it's at least guaranteed to be portable to everything that CMake is ported to without having to worry about whether Windows has a touch command or not. And I specify the dependency, the input dependency, to make sure that I'll go into this into the test later. And then finally, I add another deferred command, and I add it to the top level directory. So the same directory that has those 2 other actually running the CMake build deferred calls. And I defer a call to a function that I'm going to show you in a moment called generate code process output. So because we're not actually generating at this point in the function, I can't glob the output files at this point to see what gets generated and add them to the target. I have to wait to do that step until after the generation step has happened. But in CMake, when you do a deferred call, the deferred calls get executed in the order they were set up. So because I set up the CMake configure, CMake build in this module at the start, any calls to this function, this particular deferred call will happen later. Okay. So the post-generation work gets moved to a deferred function, but it's exactly the same. This is completely the same as the bottom bit of the original generate code function. And that's it. So how do we change our make lists, CMake lists to use this? Here's the neat part. We don't have to change it. We've basically, does anyone at Kevin's talk? Yeah, we basically completely changed something, and we don't have to change anything else that uses it, which is awesome. It's like data abstraction, but not quite. It's, yeah. Or is it yeah, it's a Liskov substitution. It's another module which if I substitute for the other one, has exactly the same effect, apart from it's better. Same semantic effect, but better performance, which is like almost an exactly example of that. Cool. Okay, yeah, I think I'm gonna, not quite so long demo. I hope, maybe. Okay, so this is the same directory, same build files, and now you all know what the purpose of Gen2 Orator directory is. So if I have a look at this, this file is basically all of the stuff that I've shown on the slides in an actual CMake module. Include guard global, though, is an important thing I didn't show you, because I do some stuff in setup, such as set up a global one-time build. I don't want to do that more than once. So if multiple CMake lists find my package or include me in a different way, I don't want to do that a second time. So there's an include guard in there. Here's the deferred CMake build stuff. And then here, so I put that setup into a function, and then I'm calling the function at the global scope in this module so that it gets set up as soon as this module is first included. And then this function, generate code process output, is the is the end step of the original function in the old module. You saw that in its entirety. And then generate code is, again, the thing that I showed you earlier. So it's got the same setup at the top of the file to make the working directory, add the include directories for this target. And then I've put a message in here. I'm saying scheduling generation for input, so the output will look much the same, but with an important kind of initial word difference. Then I create my unique identifier, and I append to the CMake lists for the custom generation step, the custom command target sources, and then I defer a call to generate process output. Okay, so that's all stuff we've kind of seen in the slides earlier. So now I'm going to do this same, whoops, okay, I lost it. I'm going to do this same build step, but instead of build, I'm going to put it in build 2, and I'm going to override the path to the generator. So I'm going to go generator root equals gen2rator. I think that's right. Should I check my slide just to see? Yeah, it looks about right. I had build 2.2 here. I don't know why I did that, but anyway. Okay, let's see if this works. It works. Beautiful. Okay, so if you look through the output here, it does much the same thing. It detects where C++ compiler is, and then at the moment that it would have called, I need more water. Reboot. And then at the moment it would have called executing generation for, it calls scheduling generation. That says that I've deferred the generation to later on. And then you can kind of look, and there are some interesting repeated lines here. There's configuring done, generating done, build files have been written to. And then slightly lower down, configuring done, generating done, build files have been written to. And that looks a little bit confusing. So the first configuring done is actually the configuration of that extra code generation project that we created. And the build files have written to, it confirms that. So the build files are written to source example2 build to code generate build. And then it runs that build, so it generates, and you can see that it's like generating the full path to the touch file. And then the next configuration done, generation done, is for the original project. And it writes the files to the top level build directory. Yes? Wait for the microphone.
Right, so if I'm following along correctly, if you were to run this again now, it wouldn't run the code generator a second time. Is that right?
If
you run the same command again, it won't run the code generator a second time. Is that correct?
So, I mean, normally I would just run a reconfigure as just running CMake build 2, but either command would work. Yes, it says.
No.
Okay, so it's gone through, it's configured the inner project, and it's written out the Ninja build file. But when it's called Ninja, Ninja has decided there's nothing to do because all of the touch files are up to date.
Mm-hmm. But then, oh, so the build files have been written to is just the end of the CMake command. Yeah, got it. It's all right.
Yeah.
Yeah.
So I'm now going to run build on build 2. I should have run with -v just for, runs the 3 steps. It's just compiling and linking. It hasn't had to do anything. However, I still retained that setting the directory property to depend on the ex2. So if I touch ex2.yaml, and then it'll run a build, I still get, I'll have to scroll up a bit actually. I still get the regenerate during build, scheduling generation, build files written, and then that generation step. And then because the header files have been updated, everything gets kind of rebuilt. Kind of as you expect. Okay, cool. I generally like to aim for 70 minutes and then have room for discussion and questions. I still got a little bit more just to kind of tidy up, and then yeah, we've had the not quite so long demo. So features omitted because of time constraints, because I thought I'd probably get to about this point. Wow, that's so almost on time. I'm kind of really impressed. So I talked a little bit about installing header files. That's something I left out of the demonstration code, but that's something that we do. And also I left off adding support for dep files for the generator. This, I think, is like really useful and really helps with, actually, let me just peek at my next slide. So actually, there's another bullet point I probably should have put here. So who's familiar with dep files or knows what a dep file is? Not too many people. Okay, I'll kind of explain it. So dependency files or dep files are basically, they're basically make files, but incredibly limited make files. And generally, you can get them when by passing some preprocessed flags to, for instance, a C++ compiler. So I think GCC, it's like -M, and there are a whole lot of variations like -M, 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 and you can specify -MT as well. Anyway, but the upshot is it generates a little makefile snippet that basically lists all of the dependencies of a particular object file. So when you compile a source file, the object file depends on the source file, but also it depends on all of those headers. And you can get the compiler to generate a little makefile snippet that expresses those dependencies. And then Ninja and Make support kind of reading those makefiles in. For Make, it's kind of like a native feature. For Ninja, it's kind of like an add-on feature where it kind of understands these miniature makefiles. And so the dep files are the mechanism by which, when you edit just a header file in your project, only those source files that depend on that header file do get rebuilt, because they might not, and just those ones. You don't have to do a clean build just because you touched a header file and are not aware of exactly which source files you need to build. On a large project, if you want a good incremental workflow, it's really important to get these things right, because who has ever debugged something, couldn't understand why on earth it wasn't working? It turned out that they weren't looking at the file version that was actually compiled into the source code. Yeah, I'm seeing it. I mean, wow, actually, I mean, it's really warm in here and it's quite late in the afternoon. Many more of you are awake than I feared, so congratulations. But yeah, it's a really common scenario. And having to do a clean build if you're on a really big project with C++ compile times, you know, if it takes 5 minutes, that's enough to go and do something else, and then you don't get back to it for half an hour. At least you've had tea, but now you've forgotten what you're doing. You're going to make some other mistake, and yeah, it's not good. If you can get your if at least you can get your incremental builds on a project really fast and very reliable, so that you know with a high degree of confidence that you're not debugging a possibly not the code I'm looking at problem, I think that's really important. So we added dep files for our generator. So I mentioned that, so in this particular toy example, only the input YAML file is the only dependency of whatever the output is. But for us, we have XSDs that can include other XSDs and all of the inputs like the generator itself and all of the, to be honest, the templates, I think I'm probably the only person who edits templates and benefits from that incremental build. So if you add dep file support, that would implement the first implementation of configure time builds to have proper incremental builds. So when you do configure and you call all of those execute. No, that's not quite true without this next feature that I'm going to talk about. Okay, but it is important for the second implementation when you do reconfigure and want to update those update only those, just run the generation steps for those whose input have changed. That det file support can be really important in terms of time saving. So the other thing that I was going to mention is we actually do another advanced feature, which should have been a bullet point here and isn't. So if you decide that you're going to regenerate something, with this toy example, the generator writes out the source file and the header file, and of course those have new timestamps and are going to cause a new compile. But what if there'd been no change to the output? You don't really want to recompile. So what we actually do in our implementation is rather than just generate into a known directory in the build directory, we actually generate to a temporary directory and then use, I think it's CMake copy if changed, or we basically try and generate to a temporary directory and then only copy over the top of the generated files if there have been actual changes, and that saves us, saves us again at compile time. Thanks for the thumbs up. And yeah, so that's another thing. All of these things are kind of designed to make it incremental builds good. Cool. So thoughts on the future directions. Fundamentally, the code that you've seen, for me, falls firmly, squarely in the rank of a cool hack. I mean, the CMake language, eval code, deferred directory stuff is stuff that I never want to research how to do ever again. I know that we are in conversation with the CMake developers, and it would be really great if something like build at configure time, or at least here's a pre-build step that you can kind of hook into that's got a defined meaning. If that became like a more supported version of CMake, that would be really cool. So my biggest concern is it's got to support, I want to be able to do things in CMake off the back of that step. So I want to be able to do, target sources, add the generate sources into my projects. I want to be able to update the install rules. So if it is like a separate first phase build step, I want another step where I can do a few more CMake configure-y things before the main build. So yeah, I mean, I think the CMake developers are definitely open to kind of moving this direction, and that's kind of really exciting, because if we move this stuff out of the realm of cool hack into something that's like something that does what I've shown, but without the cool hackiness, which is just implementation, I think it would be a lot more useful. Cool. Yeah, questions?